will beat a path to it. For many centuries, this was a lonely canyon, unseen and untouched by man, scorched by a desert sun, scolded by an angry river slashing its way to the Mother Sea. Now it lies peaceful and silent, except for the gentle hum of a hydroelectric power plant, the bubbling up of water as it leaves mighty turbines, the cheerful sounds of America and the world on the move to see this pioneer multi-purpose reclamation project man built in Black Canyon. Millions come to this once desolate spot to see this engineering wonder, to hear the story of Hoover Dam.
Ladies and gentlemen, we're now standing on the powerhouse ramp 560 feet below the top of the dam. This is Black Canyon, where Nevada and Arizona meet, where the Colorado River once flowed uncontrolled. Here is where man conquered this mighty river, placing a concrete yoke about its neck to harness its tremendous water and power resources. The water that flows through the canyon.
Through the ages, the river has gathered to its bed the snow-fed rivulets of the Rockies, flowing southwestward in its wild 1,400-mile descent to the Pacific Ocean, gouging great canyons, piling up great deltas of silt in the valleys. Early settlers were at the mercy of this untamed giant. Melted snow from the mountains each spring swelled the Colorado River into a raging torrent, flooding fertile valleys along its banks, destroying farmlands, homes, and cities. In 1905, the Colorado cut through its banks below the Mexican border and for 2 years poured unchecked into the Salton Sink, forming an inland sea. After each spring's flood, when the river had spent its fury, it dried to a trickle. Crops withered and died. Man and his livestock thirsted. All living things suffered. Settlers along the river were discouraged and aroused. Some gave up and went elsewhere. Others stayed to fight. The river had to be regulated, controlled in a year-round flow if they were to succeed. No more floods, no more droughts. Arthur Powell Davis, first reclamation director and chief engineer, understood their problem. For years, he had traveled up and down the river, surveying, studying. Build a high dam and a deep canyon upstream to control the river, he reasoned. In 1918, Davis reported his findings and proposals to Congress. Congress responded in 1928, passed the Boulder Canyon Project Act, authorizing construction of Hoover Dam to control and regulate the Colorado River, and the All-American Canal System to deliver water to farmlands on the lower river. In 1930, President Herbert Hoover, for whom the dam is named, signed the appropriation bill to begin construction. Under a contract awarded in March 1931 to 6 companies incorporated, a combine of 6 major construction firms, men and machines went to work to build this dam of unprecedented size, this modern civil engineering wonder. Reclamation engineers rushed to completion specifications and design drawings. Crews at the dam site completed their surveys and investigations. The thunder of man's determination to conquer the Colorado reverberated between the sheer cliffs of Black Canyon as construction got underway. The first major task was to divert the river around the dam site. To do this, 4 tunnels, 2 on each side, were drilled through the canyon walls. Each 56 feet in diameter, they averaged 4,000 feet in length. The drill holes were packed with dynamite and blasted. After each explosion, shovels and trucks entered the tunnels, mucked out the shattered rock, and dumped it in nearby gulches. Workmen excavated over 1.5 million cubic yards of blasted rock material from the 4 tunnels in 13 months. The tunnels then were lined with concrete 3 feet thick. Explosions rocked the canyon almost daily for 2 years, before actual placing of concrete in the dam began. Acrobatic workmen called high scalers prepared the canyon walls for each blast. Suspended on ropes, they drilled holes in the rock and loaded them with dynamite. After each explosion, these daredevils swarmed over the cliffs, prying loose rock and clearing the walls of debris. In November 1932, the Colorado River was diverted. Under control for the first time in its history, the river flowed around and past the site. Men and trucks dumped an earth and rock embankment across the canyon below the tunnel openings, forcing the river from its age-old bed through the huge diversion tubes. A second earth and rock dam was thrown across the river above the tunnel outlets downstream, keeping water from backing into the foundation area. Isolated and protected from the river by the two cofferdams, the site was pumped dry. Men and machines dug 135 feet below the old river level to reach bedrock for the dam's foundation, excavating over 2 million cubic yards of rock, earth, and sand. As cleanup of the dam site exposed the ancient bed of the Colorado River, geologists read the history of what happened ages ago. Workmen cleaned and prepared bedrock surfaces to receive the first concrete, assuring utmost stability for Hoover Dam's foundation. 12 miles upstream, drag lines excavated sand and gravel for the dam's concrete from an old streambed deposit on the Arizona side. A train hauled this raw material to an aggregate plant across the river, a few miles above the dam site. Here, the sand and gravel passed through various processes of screening, grading, and washing until it emerged as unexcelled aggregate. Then it was stockpiled according to sizes to await its trip to the dam site. This processed aggregate moved as called for in a steady flow over the railroad to two mixing plants, one in the canyon bottom and the other on the Nevada rim. There, sand and gravel were blended with cement into a uniform mix, meeting rigid specifications for the 4.5 million cubic yards of concrete to be placed in the dam structures. From the mixing plants, concrete was dispatched to all points of construction. 9 anchored aerial cableways spanning the canyon from rim to rim lowered the concrete into the forms and handled other supplies and equipment as well. As the first bucket of concrete settled into its foundation on June 6, 1933, Hoover Dam began its rise from the depths of Black Canyon. As cableways dumped load after load of concrete into the forms, the dam soon reached its full 660-foot thickness at its base. Poured in 5-foot layers of concrete, the structure's keyed or interlocking columns climbed skyward as crews set new records daily. Bucketful after bucketful ran the continuous cycle, mixing plant to canyon rim, out into midair over the gorge, and down into the forms, dumping its load of 16 tons. Crews vibrated and compacted the fresh pours, while buckets returned again and again to the mixing plants to be filled with more concrete or other waiting forms. Crews worked under all conditions, all seasons of the year without cessation, rain or shine, day and night. By June 1934, 1 year after the first pour, 2/3 of the dam's concrete had been placed in the forms. Hoover Dam had risen to an impressive height, already taking its place as one of the world's wonders. As Hoover Dam climbed between its abutments, related structures also took form. At the toe of the dam, the U-shaped power plant to house generating equipment, control, and maintenance facilities was built in twin wings, one along each side of the canyon walls. Intake towers, 2 on each side, for the power plant's penstock system, climbed as a maze of reinforcing steel and concrete. Perched on shelves hewn in the canyon walls, these graceful columns rose 403 feet, well above the dam's crest and the canyon rims. 2 giant spillways were set against the canyon walls on each side of the reservoir just above the dam. These high-level controls, each capable of bypassing 200,000 cubic feet of water per second, assure that no water will ever overtop the dam. Water flowing into the basins plunges downward through the spillway tunnels to enter the river below the dam. 100-foot-long drum gates on the spillway's crests rise during flood stage to give the reservoir an additional 16 feet of storage. Hoover Dam's penstock system called for pipes of unprecedented size, ranging from 8 1/2 to 30 feet in diameter and 5/8 to 2 3/4 inches in thickness. As it was not possible to ship units of this size across country, steel plate was brought from eastern rolling mills. A steel fabrication plant, erected especially for this job near the dam site, rolled and assembled the nearly 3 miles of pipe installed in the canyon wall tunnels. As in all unprecedented phases of Hoover Dam's construction, fabrication of the pipe sections required special machinery and equipment. Edges of the dimension plates were shaped on a planing machine to assure precision and accuracy of later steps in their manufacture. Then they were bent on a giant press and rolled into circular form. One such plate equaled 1/3 the complete circumference of a finished pipe. 3 of the largest curved plates welded together formed a ring 30 feet in diameter and 11 feet long. 2 of these rings joined made up a section weighing 150 to 184 tons. A vertical lathe machined the edges so the sections would fit precisely when joined into continuous penstocks inside the canyon walls. A train passing through one of the 30-foot sections reveals their comparative size. When the intake towers and their connected tunnels were ready to receive the penstocks, a specially designed trailer hauled the sections one at a time down the highway from the plant to the dam site. At the canyon rim, a 150-ton cableway relieved the trailer of its tremendous burdens, swung the pipe sections out over the gorge, and lowered them under absolute control. Trailers waiting at portals of the access tunnels carried them to their permanent connections inside the main tunnels. The pipe sections were hoisted into location with cables and joined end-to-end with pressure pins to form continuous conduits between the intake towers, turbines, and outlet valves. While this and other work on appurtenant features was going on, a continuous stream of concrete had been pouring into the dam forms. The structure neared its full height of 726 feet, far above the crest of any other dam yet built by man. On May 29, 1935, 2 years after they had begun pouring, crews placed the last concrete in Hoover Dam, a total of 3 1/4 million cubic yards. This modern civil engineering wonder stood completed 2 1/2 years ahead of schedule. On September 30th, 1935, President Franklin Delano Roosevelt dedicated Hoover Dam to the nation's progress. He praised its designers and builders. The dam stood like a sentinel, white and beautiful in the desert sunlight, guarding the river and its downstream wealth. Floodwaters lapped helplessly against its arched back as the reservoir filled. This man-made inland sea spread into the valleys and canyons among the colorful hills and mountains. Hoover Dam had conquered the Colorado. Turbine pits to hold Hoover Dam's 17 big hydroelectric units were built into the powerhouse. Generator installations began in 1935. The first generator, Unit N2, began commercial operation October 26, 1936, to serve the city of Los Angeles. In ones and twos, the generators filled the pits as demand for electrical energy in California, Nevada, and Arizona called them into service. Finally, in 1959, manufacture and installation of the last generator, N8, began. For 25 years, the N8 pit had lain dormant and silent, except for the hum of other Hoover generators. Now, as more generating capacity was needed, contracts were awarded for the generator's manufacture and installation. Plants throughout the nation fabricated N8's many parts. The design of N8 followed that of other Hoover generating units. It is a 95,000 kilowatt, 60-cycle, 16,500 volt generator driven by a 115,000 horsepower turbine. Falling water from the reservoir, which spins and powers the turbine wheel, is controlled by a huge butterfly valve, which permits the water to flow to the turbine from the feeder penstock. Weighing 2,000 tons, N8 parts were shipped to Hoover Dam on 60 rail cars. Arriving at the canyon rim overlooking the dam, the parts were lifted by cableway out over the canyon and down to the powerhouse. Parts descending into the gorge on strands of cable were familiar and almost daily sights, reminiscent of previous installations. And the main cableway operator was the same one who had helped install and operate the cableway during the dam's construction in the early 1930s. Others likewise had worked on the project throughout its construction. Inside the Nevada wing of the powerhouse, technicians assembled and installed the mass of electrical cargo. Crews prepared the N8 pit to receive the new generating unit. They removed temporary slabs over the turbine and relief valve outlets to the tail race or river. Liners assembled in these openings were set in concrete. The turbine's scroll case sections were lowered into the pit. The sections were leveled, bolted together, and aligned. The completed scroll case was then anchored in concrete. Later, the turbine's water wheel, attached to the bottom end of the shaft, was installed inside the case. The butterfly valve was assembled on the generator floor and later connected between the feeder penstock and the turbine's scroll case. Meanwhile, the generator's two main parts, the rotor and stator, took form. Steel lamination plates were stacked around the rotor and stator frames. Coils were locked into place and electrical connections were made. The powerhouse's overhead cranes lifted the completed 254-ton stator from its erection bay and carried it gently to its foundation over the turbine pit, where it was lowered and bolted into place. The 466-ton rotor was moved from its erection bay and lowered inside the stator. The rotor was then joined to the turbine water wheel by a 38-inch diameter shaft, 63 feet long. Guide and thrust bearings and other parts were added to complete the assembly. After test runs, N8 went on the line December 1st, 1961, to serve the state of Nevada and to complete the Hoover power plant, raising its capacity to 1 1/3 million kilowatts, keeping it as one of the world's largest hydroelectric installations. As the last sounds of construction faded into history, Hoover Dam had cost $175 million. Less a deferred payment of $25 million allocated to flood control, Hoover Dam's cost is being returned to the federal treasury at 3% interest from the sale of hydroelectric power. Hoover Dam has fulfilled the hopes and expectations of those who envisioned this great reclamation project. Colorado River waters that once destroyed man and his property now serve him. The Colorado pours its waters into Lake Mead, named for Dr. Elwood Mead, Reclamation Commissioner during construction. Lying calmly behind the dam, these waters await need by downstream users. Water is released through the Hoover Power Plant turbines in a year-round flow to irrigate over 1 1/4 million acres of desert land, serve municipal and industrial needs of the Pacific Southwest, generate hydroelectric energy, and provide various other multi-purpose benefits. The clear waters of Lake Mead have opened up a vast new recreational fish and wildlife vacation land for America. Millions beat paths to this one-time wilderness along the Colorado River to picnic, go boating, swim, fish, and enjoy these important outdoor reclamation products. Hoover Dam and its power plant work around the clock to serve water and power needs of the Pacific Southwest. Water from Lake Mead, passing into the intake towers, falls over 500 feet through the penstocks to spin the giant turbine wheels and then discharge to the river. This action is repeated at downstream reclamation dams. Transformers step up Hoover Dam voltage as it comes from the generators. Lines carry this power up over the powerhouse roof to the switchyard. From there, it is transmitted over lines across the desert. The river flows southward, and along the way, man diverts from the controlled stream to sustain his prosperous way of life. 67 miles downstream, Davis Dam re-regulates the Colorado's flow, releasing water through its power plant turbines to irrigators in this country and Mexico. Davis Dam generators interconnect with those at Hoover Dam upstream and those at Parker Dam downstream. This energy goes out over transmission lines of the Parker-Davis project to farms, homes, and factories. Much of this Colorado River energy pumps the farmers' irrigation and drainage water. Parker Dam, 155 miles downstream from Hoover Dam, was built with funds advanced by the Metropolitan Water District of Southern California. Parker Dam provides a forebay for the district's Colorado River Aqueduct, another one of America's 7 modern civil engineering wonders. Electrical energy from Parker and Hoover power plants pumps water along the aqueduct. This waterway delivers municipal and industrial supplies to the Los Angeles and San Diego coastal areas. Parker Dam also controls floods. Below Parker Dam, Headgate Rock Dam diverts water to Colorado River Indian Reservation lands in Arizona. And farther downstream, the Palo Verde Diversion Dam sends water to the Palo Verde Irrigation District, oldest irrigation development on the Colorado River. At Imperial Dam and Desilting Works, 300 miles downstream from Hoover Dam, Colorado River water enters river-sized canals to irrigate farmlands in California and Arizona. The All-American Canal System carries part of the Colorado's flow westward to the Yuma, Imperial, and Coachella valleys. When water reaches its farthest point on this canal system, it has traveled nearly 500 miles after leaving Hoover Dam and has required 10 days to make the trip. The Gila Gravity Main Canal takes water from Imperial Dam south and east to valley and mesa lands of the Gila and Yuma auxiliary projects. Mexico's share of Colorado River water to irrigate lands below the border passes Imperial Dam, and most of it is diverted at Morelos Dam into the Alamo Canal. The non-surplus food, fiber, and forage crops grown on lands nourished by water from Hoover Dam find ready markets throughout the nation. While snow-covered lands lie idle, winter fruits and vegetables grown in the warm Southwest with Colorado River water are shipped to dinner tables across the nation. In return, these irrigated areas buy farm machinery and other products from the manufacturing centers. This exchange of goods between West and East, North and South, has helped develop America's free enterprise prosperity. Hoover Dam has pointed the way to the fullest utilization of the Colorado River's resources. Man is adding other mighty reclamation projects to the stairway of dams on the Colorado River. In northern Arizona, Glen Canyon Dam has joined Hoover Dam in conquering and regulating the Colorado. Potential sites in other canyons on the Colorado River await the day when they too will cradle mighty multi-purpose dams. These developments will write new chapters in the story of Hoover Dam, truly a modern civil engineering wonder.